Hello and welcome back to another video. In this problem, we're asked to prove the statement using the precise definition of a limit. We have the limit as x approaches 10 of 3 minus 4/5 x is equal to negative 5. So the precise definition of a limit states that the limit as x approaches a of f of x is equal to f if for every number epsilon greater than 0, so any positive number you put in greater than 0, there is an associated delta greater than 0, such that if 0 is less than the absolute value of x minus a is less than delta, then the absolute value of f of x minus L is less than epsilon. So what does this mean for the actual problem? Well, a here is the value which x is approaching, so that's 10. And f of x is the function, so 3 minus 4/5 x. L is the value the limit approaches, so negative 5. This is less than epsilon. And so what we have to do is create a relationship between delta and epsilon to say, okay, for every epsilon, you're going to have this delta. So what we have to do here is first we can simplify this. So this is 3 plus negative 5, so that's 8 minus 4/5 x is less than epsilon. So what we need to do is these inequalities need to match. So what we have to do is we have to eliminate this part of the inequality. If we're saying that the absolute value of x minus 10 is greater than 0, this is basically like saying that it's not equal to 0, because it's already greater than all the negative numbers. So we're just saying this, which means that x minus 10 is not equal to 0, and x is not equal to 10. However, since this is the limit as x approaches 10, not actually what's happening at x equals 10, we don't have to worry about this, and we can just ignore it. So we have that the absolute value of x minus 10 is less than delta, and the absolute value of 8 minus 4/5 x is less than epsilon. So we have to get these to match. So if we multiply both sides of this equation by 5 over 4, we have 5 times 8 over 4 is 40 over 4. And then 5 times 4 over 4 times 5, right? This just cancels. 5/4 times 4/5 is just 1. So this is minus x. The absolute value of this is less than 5/4 epsilon. And we can multiply this number into the absolute value because it's positive. It doesn't affect the nature of the absolute value. 40 over 4 is 10 minus x, and this is less than 5/4 epsilon. This is very close to this, 10 minus x, x minus 10, but we have to multiply it by the absolute value of negative 1. We do this because the absolute value of negative 1 is just 1. So here, this is just 5/4 epsilon times 1, so that just stays the same. But we can distribute this in to the original absolute value to get negative 1 times negative x is positive x, negative 1 times 10 is negative 10, and I just swapped them around, which you can do with addition, to get that x minus 10 in an absolute value is less than 5/4 epsilon. If the absolute value of x minus 10 is less than delta and it's less than 5/4 epsilon, we can say that delta equals 5/4 epsilon. And to prove this, we have to plug it into our original function. Absolute value of x minus 10 is therefore less than 5/4 epsilon, right? Plugging it in for delta. If we multiply by 4/5, we get 4/5 x minus 4 times 10 over 5 is less than, and again, 5/4 times 4/5 is just 1, is less than epsilon. We then have to multiply both sides by the absolute value of negative 1 again to get that negative 1 times negative 40 is positive 40 over 5 is positive 8 minus 1 times 4/5 x is minus 4/5 x. This is less than epsilon times absolute value of negative 1, which is just epsilon. Therefore, 8 is equal to 3 plus 5. Therefore, we can say this is equal to 3 minus 4/5 x. So these two, plus 5, we can write as minus negative 5. And therefore, 3 minus 4/5 x is f of x, negative 5 is L. Therefore, f of x minus L, the absolute value of that, is less than epsilon. And therefore, we know that this relationship is true.